Hi there. Let's talk about limits. I'm going to introduce the idea of what is a limit. And I have two examples to show us to help think about that. Okay, here they are. So the first example is f of x is 1 over x. So hopefully you've seen this graph before. This is an asymptotic type graph. And it has the point 1, 1. And at 2 it's 1/2. And the larger the x gets, the smaller and closer to 0 this one gets. And the closer to 0 it gets, the larger it gets, positively. And at the point -1, y is -1. And it does the same thing. You can try this at home if you want to do a table of values or use a graphing calculator. But the important thing is to look at this. Okay, so we write this, the limit of f of x as x approaches 0 plus. So this means we're talking about f of x, this 1 over x graph, and we're asking what happens as x approaches the value of 0. So if I plugged in 0 into 1 over x, I would get undefined. But I'm not plugging it in, I'm approaching. And you see how I wrote 0 plus? That means I'm thinking I'm starting from the right side and x is moving. And on the graph, if x starts here and it's moving this way, the graph of f of x approaches infinity. We say positive infinity. Now, if we started from the other side, from here, and went that way, we would not get positive infinity. It goes down to negative infinity. So we would get limit as x approaches 0 from the negative side, that is from here, f of x approaches infinity negative. Okay. We can also ask about what happens when x goes towards infinity or towards negative infinity. So we write the limit as x goes to positive infinity of f of x. And again, we can't plug in infinity, but we can ask what happens as x approaches. You just think x keep on going in that direction. And on the graph we see as x goes bigger and bigger and bigger, f of x gets smaller and smaller and smaller. So as x approaches infinity, f of x will approach 0. The same will happen with the negative. As x approaches negative infinity, f of x will approach 0 as well. Okay, that's our first example. So our second example here is g of x. And I've just drawn some interesting function. It's a piecewise function, so it's got different pieces. So we can think about so we can think about a number of different things here. So maybe the first thing, the limit as x approaches infinity of g of x. So what happens as this one gets bigger and bigger and bigger? Well, g of x is going to keep increasing and keep getting bigger. So this guy will approach infinity. And how about at the value 1? Here x is 1. Well, it's kind of interesting looking. As x approaches from the positive side, it comes to this point here. But as it approaches from the negative side, it comes to this point here. So the limit as x approaches 1 from the positive side of g of x is equal to this y value here, which is 1. But from the negative side, as x approaches 1 from the negative side, g of x is equal to 3. And notice, what happens if I plug in x is equal to 1? That is, you see, these are open holes. The filled-in hole implies the mathematical term is closed. That is, if I plug x as 1, the value that I get out of g is actually the dot there. So when I plug in, we get 2. So the limit from the right side is 1, the limit from the left side is 3 at that point, and the value itself is actually 2. So all three of those are different. Limit from the left, limit from the right, and the value. Okay, Next point that's kind of interesting is this one. X is negative 2. So the limit as x approaches negative 2 from the positive side, that is here, what's that? That's 3. Of g of x equals to 3. And the limit as x approaches negative 2 from the negative side of g of x, what's that? That's coming up from here, approaching to this point. And that's 2. Now in this case, if I ask what is g of negative 2, then I plug in where I see the closed dot, the filled-in dot, and that's actually the same as the limit from the left side. That's just 2, y equals 2. Okay, there's a whole bunch of examples. So when I do a limit, I imagine there's a bead on the function, and I move it towards the point that I'm interested in. And then whatever place that bead gets to from that direction, that's the value of what I get.